Welcome back to Aurora Tech Channel. Today, I will review the QiDi X-Smart 3. This is the smallest and lowest priced machine in QiDi's new Clipper series. Previously, I reviewed the X Max 3 and X Plus 3. The X Max 3 is a robust machine that is ranked third on my recommendation list on AuroraTechChannel.com, which only recommends 8 3D printers out of the over 100 machines that we have reviewed so far. The X Max 3 is priced at $950, while this X Smart 3 is only priced at $399. Let's see what we can get from this sub-$400 machine. It's a fully enclosed mini machine with a print volume of 175 by 180 by 170. The motion system uses linear rods on the Y and Z axis, and the X axis uses carbon rods like the BambuLab X1. The machine only weighs 23 pounds, which is pretty light for a fully enclosed printer. The enclosure has an exhaust fan, so you can turn the fan on to lower the chamber temperature by exhausting heat out, or you can turn it off to trap more heat inside. The claimed maximum print speed is 500 milliliters per second. The extruder is a 9.5 to 1 low gear ratio direct extruder, and the hot end is using a ceramic heating core instead of a regular heat cartridge, and the maximum flow rate is 30 millimeters cubed per second. The maximum nozzle temperature is 300 degrees Celsius, but the machine only comes with brass nozzles, so there's no high temperature hot end equipped with a hardened steel nozzle. The cooling fan is a turbo blower, and it does not come with an extra auxiliary fan. For the print bed, it's supported by a dual Z axis, and it uses a timing belt to synchronize both sides of the bed. The maximum bed temperature is 120 degrees Celsius. There are no leveling springs under the bed for manual leveling, so it relies solely on the inductive bed leveling sensor. It also doesn't have the auto Z offset, so you still need to use a paper or card to set the Z height. The print surface is a black-coated double-sided PEI spring steel sheet. The motherboard is MKS Pi with an A53 1.5 GHz quad-core processor with 8 GB of eMMC and 1 GB of DDR3 RAM. The touchscreen is 4.3 inches, and it runs a custom touchscreen UI instead of the standard Clipper screen UI. I would like to thank QiDi for sending me this machine to review, and I would also like to thank Sunlu for sponsoring today's video. Sunlu has been involved in the 3D printing industry since 2013, so if you've been part of the 3D printing community for a while, you might be familiar with their filament. They have their own factory and a dedicated R&D team that stays up to date with the latest market trends. Personally, I really like their recycled filament series, which are priced at an affordable price of $9.99 per roll, as I appreciate the idea of reusing plastic to help the environment. Besides that, Sunlu also offers a wide range of options, including regular PLA, strength-enhanced PLA+, carbon fiber-filled PLA, and other more unique choices like twinkling, silk, rainbow, and wood-filled PLA. They offer PETG, ABS, ASA, and flexible TPU filaments as well. They also provide accessories like filament dryers and various types of 3D printing resins. For more information, please visit sunlu.com. The machine is protected with styrofoam. Personally, I prefer custom laser cut foam, but thankfully there aren't any of those annoying small pieces of styrofoam flying around. The machine is packed inside a bag, but it's not thick enough for you to just lift the machine up with it, so you need to grab the bottom carefully. But the machine is pretty light at just around 20 pounds. The motion system and the print head are secured with zip ties, some cardboard, and bubble wrap. We need to remove these, as well as the 4 screws at the bottom used to secure the print bed. The power voltage switch is at the bottom, so make sure to check that it matches your local voltage before turning it on. Once the machine boots up, it shows the select language screen and reminds you to remove the protective materials. There is one last piece of foam at the bottom of the bed, so you need to raise the bed to remove it. Then, it requires you to manually heat up the bed before calibrating. It will start by setting the Z offset. Since this machine has no auto Z offset feature, you still need to do the paper test. Like all QiDi machines, a leveling card is included. Next, it will do 16-point auto bed leveling, and a 4x4 mesh will be more than enough for this tiny bed. After that, it will calibrate the input shaper with the built-in accelerometer inside the print head. The screen will just freeze like that, but you will hear different frequencies when the print head moves. After around 7 to 8 minutes, it's done and it'll save the settings. We can now load some filament. The spool holder is snapped at the back of the machine, so you need to run it through the filament runout sensor, and the Bowden tube will work as a filament guide to the direct extruder. Okay, we can now set up the Wi-Fi. Go to Settings, Network, click on the refresh button, select your SSID, enter your password, and after a while you will see an IP address here. This is just to confirm your printer has connected to your Wi-Fi successfully. You don't need to remember it, as the slicer will search for your printer automatically. QiDi sent me this machine a few months ago, and I just didn't have time to open it up until now. But I believe there are already a few firmware updates released, so I will go to their website and download the latest one. You still need to do this the traditional way. Download the file, copy it to the USB drive, and once you insert it back into the machine, you can load the firmware. Then, you need to power off the machine, and don't turn it back on immediately, as you need to wait for 20 seconds to let the power supply turn off completely, or the motherboard will still have power. After you turn it back on, it's going to reinstall the OS, which takes exactly 20 minutes for my machine. The firmware version has now been updated from 4.1.0 to 4.1.10. Okay, let's do a test print. There's a Benchy preloaded, and I will skip bed leveling as we just did it. For a fully enclosed printer, you have to remove the top cover or the interior temperature may get too high for printing PLA, which could clog the nozzle. Just confirm and wait for the print to start. Once it finishes the first 2 layers, the machine is printing at a high speed. I will check the sound level. When the top cover is removed and the door is open, the sound level stays between the mid to high 50s and the high 60s. When it's fully enclosed, it stays between the low and high 50s, which is around 10 decibels lower than when it's fully opened. The print finishes in 17 minutes, which is pretty fast. The print's not bad, but this machine doesn't come with an auxiliary fan. There are some minor cooling issues, and there are a few imperfect layers, but the rest of the surface looks alright. When I turn it around to show you the back, you can see that the layer imperfection is actually caused by the Z-seam. The front cooling is perfect, but again, the Z-seam shows up here. Besides that, the overhang also has some minor cooling issues, but overall it's not too bad. Let's compare it to other mini-sized printers. When compared to the BambuLab A1 Mini 19-minute Benchy, this printer was faster and the surface quality is similar, but the cooling of the A1 Mini is better. When compared to the Prusa Mini Plus with the latest input shaping firmware, the X-Smart 3 has better surface quality, print speed, and stringing. When compared to the Kingroon KP3S Pro V2, which uses the same MKS Pi motherboard to run Clipper, the X-Smart 3 is once again the winner in terms of print speed, print surface quality, and cooling. So, I would say this Benchy is not the best, but it is better than most fast mini bed slingers like the KP3S Pro V2 and even the Prusa Mini. Next, I will set up the new QiDi slicer on my computer, and it's a skin Prusa slicer with some cosmetic changes. I will just set up the Wi-Fi to print over the network. Add a physical printer, use the X-Smart 3 profile and give it a name. The host type is Clipper via Moonraker, and for the IP address, you can enter it directly or use the search feature. Click the test button, and the connection is working normally. Okay, I will then do a clearance test, the number slider. There are 2 profiles for the 0.2mm layer height, fine and normal, so let's take a look and see what's going on here. Let's do a comparison. It seems the infill and travel speed of the fine profile is even faster than the normal one. The other settings have no big difference, so I'll just stick with the fine profile. The speed is set from 200 to 300 milliliters per second, the first layer is set to 50 milliliters per second, which looks normal for a new Clipper Core XY machine. The default acceleration is set to 10K, and the external walls, bridge, and first layer are slowed down accordingly. For the generic PLA settings, the volumetric speed is limited to 14, which will limit the actual print speed to around 175 milliliters per second. I will leave everything unchanged and just test with the default profile. The estimated time of this print is around 2.5 hours, which is in line with other Clipper machines. Let's send it to the printer. Like most other 3D printers, the Wi-Fi module only supports 2.4 GHz network, so uploading a 15 MB file will take around 30 seconds. It's not super fast, but it's still faster than copying the file to a USB drive and going back and forth from your computer to the printer. It looks like the first layer is a bit too low. I didn't see that when printing the Benchy, so I will keep adjusting the Z offset on the screen to fine-tune the first layer. After moving the bed 0.06 millimeters away, it looks much better. I will just keep this distance and let the print finish. The print finished in 2 hours and 26 minutes, which matches the slicer's estimated time. The print looks alright. There's a tiny bit of stringing on the surface. The bottom looks nice, and it seems the slightly lower Z offset didn't have any impact on the bottom surface. The clearance is also excellent. Then, I will do a retraction test and print a Honeycomb box with Sunlu Gold PLA. When sending the print directly from the slicer, the starting G-code has G29, so you have to remove it if you don't want to do bed leveling before every print. The print finished in 2 hours and 46 minutes. There is some stringing between the Honeycomb, similar to the other QiDi machine, the X-Max 3, that I tested before, but all of it was still printed without any broken patterns. There's more stringing than the Prusa MK4, but the MK4 did have some broken patterns. The BambuLab A1 Mini printed this model the best. Let's take a closer look. I would say the retraction of this extruder is pretty average. It can finish this tough model, but the result is neither the best or the worst. Next, I will print the Robo Alpaca from Prusa. For this kind of decorative print, we will mainly test the print surface quality. As the maximum Z height is 170 mm, I will scale down the model from 200 to 170 mm. the print finished in 3 hours and 14 minutes. The full-size model would take around 4 to 4.5 hours on most other printers. The print quality is pretty good. It's not far from the Prusa MK4, which took 7 hours and 50 minutes to print the 200mm tall model. However, there is still some slight ringing that I don't see on the Prusa model. The print quality and speed are in line with the BambuLab A1 Mini, except for that ringing in this area. When compared to the P1P, I think the overall surface quality of the X-Smart 3 is a little better, and it's also better than the Ankermake M5C, which took almost 6.5 hours to print the full-size model. So in terms of print surface quality, it's better than average. The print speed is also on the fast side among all new generation printers. Then, I will print a Voronoi cat model with the same Sunlu Gold PLA. This is also a decorative model with some retraction, not an excessive amount like the Honeycomb box, but more than your average model. The print finished in 5 hours and 46 minutes. The result is decent, and the stringing is much better than the Honeycomb box, so it seems the extruder can handle this model without issues. Compared to the one printed by the BambuLab P1P, which took 5 hours and 57 minutes, it's slightly faster. The results are very similar, but when zooming in really close, the stringing of the P1P is a little better. However, both of them are still pretty good prints. Up next, I will try some different materials, starting with a wallet using Eryone TPU. This is not vase mode, as I printed 3 bottoms and 2 walls with no top and no infill. The volumetric speed of TPU is set to 6mm³ per second by default, so the maximum print speed will be limited to 75mm per second. The result is pretty nice. I just used a box to make this model in the slicer, and I may have entered the wrong height in the Z-axis, so this wallet is super long. But the extrusion is good, and there are no issues with this print. Then, I will test PETG using Sunlu Green PETG. The volumetric speed for PETG is set to 10, so the maximum print speed is limited to 125mm per second. This tire pen holder finished in 2 hours and 49 minutes, and the result is awesome. Even when zooming in this close, I can't find any imperfections, so this is a very nice print. One advantage of a fully enclosed printer is being able to print ABS. I will use Sunlu Black ABS to print a mesh crate. With some glue applied, the print stuck perfectly. As the ambient temperature is stable, there's no warping on all corners and no cracking and layer separation. Besides a tiny bit of stringing, the crate looks really good. As the maximum nozzle temperature is 300 degrees Celsius and the maximum bed temperature is 120 degrees Celsius, it will be ideal for printing polycarbonate. I will use Prusa PC to print a pair of nose pliers from 3dprintedhardware.com. As this enclosure is tiny, when I set the heated bed to 120 degrees Celsius, once the print starts for a few minutes, the interior temperature can reach over 55 degrees Celsius. During the print, the temperature goes up to 64 degrees Celsius, but it won't go any higher. If you're printing something that's better in a lower chamber temperature, you can turn on the exhaust fan, which will bring it down to around 50 degrees Celsius. This print is excellent, and with a tiny enclosure that traps heat extremely well, it prints polycarbonate as if it was PLA. The layers are perfect, and after the support is removed, the pliers are fully functional. finally, I will do a first layer test. At first, I started the print and kept adjusting the Z offset to fine-tune the first layer. After I felt that it was perfect, I restarted the print. The first layer that used up the whole print bed at an 175 by 180 size took only 13 minutes. It looks almost perfect, but when I try to peel it off, a few lines were separated and it seems the Z offset is still a bit high. I lowered it by another 0.03 millimeters and restarted the print. This time, the entire first layer is perfect. I can peel it right off, and it's like a PLA sheet with all lines perfectly connected to each other. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. My favorite thing was the tiny enclosure. It traps heat very well, and even though it doesn't have an actively heated chamber like the $1,000 X Max 3, it works just as well. It handles tough different materials like ABS and polycarbonate very well, and especially when printing polycarbonate, as it's doing much better than most other printers I have tested. There's also an enclosure fan, so if the chamber temperature is higher than what you want, you can just turn it on and still maintain a 50 degrees Celsius chamber temperature when the bed is set to 120 degrees Celsius. 2. The machine has Core XY kinematics, and the motion system also uses the same carbon rod as the BambuLab X1, P1P, and P1S, so it's lightweight. With the linear rods on the Y-axis and the Z-axis only moving up and down, the print quality is still pretty decent when printing at high speeds. 3. It requires no assembly. Just take it out of the box and run the setup wizard, and it's ready to print in around 20 minutes. 4. The network workflow is pretty good, as they just use a skin Prusa slicer and kept the Moonraker plugin, which is honestly better than other manufacturers trying to reprogram Clipper firmware and ending up making a mess. 5. Even with just a 350 watt power supply, the heating time of the nozzle is super fast. From 25 degrees Celsius room temperature to 220 degrees Celsius, it only takes 49 seconds. Even for heating to 300 degrees Celsius, it only takes a minute and 30 seconds. The tiny bed also heats quickly. Heating from 25 to 60 degrees Celsius takes a minute and 20 seconds, heating to 100 degrees Celsius takes 3 minutes and 35 seconds, and even heating to the maximum 120 degrees Celsius only takes 5 minutes and 40 seconds. It can be challenging for a lot of printers to heat up to 120, which is why most machines you see in the market only let you heat up to 100 or 110 degrees Celsius. 6. You can easily access the Linux operating system via SSH with the default username and password, which is handy. For example, if you want to synchronize the time over the internet, you can do so by simply installing the Network Time Protocol or NTP service. Or run a monitoring utility just like how you use a Linux computer. Now for the cons. 1. The firmware used in this machine is new generation Clipper, which is a good thing, but the touchscreen interface still uses an older approach that makes it function more like a G-code sender. During the setup wizard, it provides basic information, but it can still be improved. For example, it asks users to manually heat up the bed before performing tasks like Z offset and bed leveling, which is unnecessary as these steps could be automated. Additionally, when calibrating input shaping, the screen doesn't show any progress or data from the Clipper firmware. This results in the screen freezing for about 6 to 7 minutes. If the machine were to use a standard Clipper screen, it could use data and feedback from the Clipper firmware and enhance user experience while setting up and throughout general usage. 2. The firmware updating process is also outdated. It involves manually downloading the firmware file, copying it to a USB drive, turning the machine off and back on, and waiting for 20 minutes for it to reinstall the entire operating system. I'm honestly pretty confused why I'm doing this on a machine connected to the internet. I can't see why the firmware is not being pushed from the server and updating itself automatically like most other new generation machines. 3. The Z offset is saved on the screen, and when you check the printer.cfg file within the Clipper firmware, you'll notice that it's always set to 0. The way it works is the screen transmits the Z offset value to the machine every time it boots up, but this setup can lead to problems. As the fluid web interface can be accessed through a browser or within the slicer, if the user adjusts the Z offset value and saves the setting here, it can cause issues and mess up the Z offset. This is another problem caused by the touchscreen with an outdated approach. 4. There is no auto-Z offset feature. While experienced users can manually fine-tune the Z offset using a piece of paper or even after the print is started, too many new generation machines in the market do offer auto-Z offset, even something like the sub-$200 Ender 3 V3 SE. The absence of this feature makes the printer seem somewhat outdated in comparison. 5. The hot end and extruder are the same as those in the $1,000 X Max 3. However, this printer just comes with one hot end with brass nozzles. I understand that the manufacturer needs to put their machines into different classes, but omitting a relatively inexpensive high-temperature hot end with a hardened steel nozzle and not letting this printer handle materials like nylon carbon fiber and other abrasive filaments is a questionable choice. The manufacturer may assume that users can buy higher-end models like the X Plus 3 or X Max 3 if they want that feature, but in reality, users might just walk away. In this highly competitive 3D printer market, you're not just competing within your own product lineup, you're also competing with the hundreds of other 3D printers available. In conclusion, this machine demonstrates impressive capabilities, handling challenging materials like ABS and PC very well, and still getting decent results with standard materials like PLA, PETG, and TPU. Most test prints I did on this machine turned out pretty good, with the exception of the Honeycomb box, which is a super tough model that requires excessive retraction, and that print still fell within an average performance range. I didn't encounter any major issues with this machine. The other minor issues were mainly due to their self-developed touchscreen, which uses an outdated approach. As a new generation mini 3D printer, it's unavoidable for potential buyers to compare it to all available options in the market. In my opinion, when it comes to tech, the BambuLab A1 Mini stands out among all mini printers, but it does have drawbacks. The print bed can only reach up to 80 degrees Celsius, and currently you also have to purchase it with the AMS combo, which costs $460 in total. In contrast, the X-Smart 3 offers an 120 degrees Celsius heated bed and a small enclosure capable of maintaining high ambient temperatures better than regular enclosures. It can print a wider range of materials and is available for around $400. Honestly, I still can't see QiDi or anyone else in the 3D printer market surpassing BambuLab in terms of R&D in the foreseeable future. But the only way to make this machine more attractive and compensate for some of its slightly outdated features is to include additional hardware in the same package and increase the machine's value. For example, adding an extra set of hot ends with a hardened steel nozzle would transform this machine into the full package. This move would give it an edge over other open-frame mini printers. When you visit my website auroratechchannel.com, you'll notice that I recently introduced a 3D printer price tracker and a comprehensive comparison tool for most common 3D printers. While searching for a mini 3D printer priced under $400 with Clipper firmware, Core XY, linear motion system, a high-temperature hot end, and a full enclosure, the X-Smart 3 could potentially be the only machine that fulfills all of this criteria. If you're interested in this X-Smart 3, you can find the link in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time. I would like to thank QiDi for sending us a machine. I would like to thank QiDi for sending me the machine. I would like to thank QiDi for sending me the machine to review. I would like to thank QiDi for sending me this machine to review, and I would also like to thank Sunlu for sponsoring today's video. You can easily access the Linux system's operating system through the You can easily access the Linux operating system through the You can easily access the Linux operating system through SSH with a default username and